Hello students, I am Reena. Welcome to Math Fam. This is your area related to circle chapter here. Let us see what you have learned here. We are going to recap all the most important part here. If you see circle, you should know in a circle when we are talking about the mensuration topic, you should know diameter is double the radius. So to calculate the radius, we always divide diameter by 2. So what is the area of a circle? Area of circle is pi r square and the circumference of a circle is always 2 pi r, where you take pi value as 22 by 7, or if they have given 3.14, you are going to consider 3.14. Now from these formulas you can have your area of a semicircle. So semicircle is nothing but when the circle is divided by a diameter, this is your semicircle, where the central angle subtended by the arc is 180 degree. Here this is 180 degree. And how do we calculate the area of a semicircle? You take the area of circle, divide it into two equal parts, right? So you'll have it as pi r square by 2. Then how do we find out the perimeter of a semicircle? It is the arc of the circle, which is semicircle, and you will take the diameter, which is 2r. So what is going to be the half of the circumference? It is 2 pi r by 2, because if you take it here, this is half of the circumference and going to be pi r plus 2r. R can be taken as common and then you can have pi plus 2. Similarly here, what is the quadrant circle means? It is 1/4 of a circle. So central angle is always going to be 90 degree. Then how do we calculate the area of the quadrant? Because here circle is divided into 4 equal parts. So the area will be 4 equal parts. So which is going to be pi r square by 4. Perimeter of the quadrant, then you take this, then 2r and this arc, right? This arc is nothing but when the circumference divided into 4 equal parts, so 2 pi r by 4, which is pi r by 2 plus 2r. So now which kind of MCQ question can come from this topic? If you will see here, if the radius is half, right? If it's a half, then find out the area of the circle. What is the percent change? So that means the original radius is r and the original area will be pi r square. So you say radius becomes half, that means r by 2, radius is r by 2, so the which is 1/4 of original area. Now there is definitely the 1 time pi r square is becoming 1/4, means there is a decrease. How much decrease is there? You can do the subtraction, because this is 1 time area becomes 1/4 of original area. So you can do the subtraction to find out the change, which is 1 minus 1/4 is 3/4. Now, how to calculate the decrease percent? 3/4 of area by original area. This gets cancelled. So you are left with 3/4 of 100%, which is 75%. So how much decrease is there? 75%. That means we take here, you can directly also take, this is 100% and 1/4 is here 25%. So decrease is 100% minus 25%, which is 75%. Or you can take, now after that, this kind of MCQ question can come. If the radius is increased by 20%, the area will increase by dash percent. How do we do it here? Then again you take the original radius is r, increased radius will be r plus 20% of r, which is nothing but 120% of r. So you get it as 1.2 r. So your r radius is becoming 1.2 r. The increase. Now here it will be pi r square. So r is becoming 1.2 r. So 1.2 square r square, because we always do the comparison with the original area. So what is the area here? Area has become 1.44. So the pi r square is becoming 1.44. That means the change is 0.44 times 100% will give you 44% increase in area. Now after that, what is the meaning of arc length? Here arc length is nothing but the part of the circumference here. Now if you see, this arc is subtending angle theta at the center. So if I need to find out this arc length, which is a minor arc because it's less than semicircle, you use the formula theta by 360 to pi r. Why do we have this formula? If you will see this theta angle, this is nothing but out of 360 degree, and this arc length is nothing but the part of circumference, right? So that's why we take fractional value, which is theta by 360 of 2 pi r, circumference part, right? Now how to find out the major arc length? Either you can take here, because you are having here minor arc length, so you can take here 2 pi r minus minor arc length, or because this angle here, if you see here, this angle is 360 degree minus theta, so directly you can use the formula here, 360 minus theta by 360 into 2 pi r. So either one you will reach the same answer. Then how do we calculate the area of a sector? You know that the sector is nothing but the area enclosed between two radii and one arc. This is the area. Again, theta part out of 360 degree. This total is 360 degree. You are taking here theta out of 360 because it's a part of area. So you will take here pi r square, because you can have the area of major sector also. If the angle is more than 180 degree, directly this formula will become the major sector formula. Here I have taken minor sector, so it's a theta by 360 pi r square. Now if the minor sector is given, how will you calculate the area of major sector? You can take here the whole circle area, which is pi r square, an area of minor sector which I have taken it as theta by 360 into pi r square, right? Or because this angle is going to be 360 minus theta, I can directly take here 360 minus theta by 360 into pi r square if it is a major sector given. Now how do we, sometimes they ask you what is the perimeter of a sector also, these kind of question, and case study based questions. So perimeter of a sector, you will not take only the arc length, because when we are talking about a sector, perimeter is the length enclosed, the length of the boundary for a closed figure. So you will take your arc length, then you are going to take, consider here 2r also, then it's a closed figure. So what is the perimeter of a sector here? Arc length plus r, which is theta by 360 2 pi r. Right now, how do we calculate the area of minor and major segment? You know that the segment is always the area between a chord and the arc, right? So here, if it is less than semicircle, we call it as minor segment, and this arc is subtending theta angle at the center, right? So how do we calculate this area? You have already seen how do we calculate the area of sector. Now here, area of sector OAB, you know that it will be theta by 360 into pi r square. Now from this sector, if I remove this triangle area, I'll be left with minor segment, right? So this is the formula. You have to just remember, area of sector minus area of triangle is going to be area of minor segment. So theta by 360 pi r square minus half base into height, or this is the area of triangle OAB. If it's a right triangle, or calculate the area of major segment. Now here, if you see, major segment is other than whatever is minor segment is there, because it will be the area between this arc, my major arc, and the chord, right? This is your, this whole area is your major segment area. How do we do it here? You will take area of circle minus area of minor segment. So area of circle is pi r square, and from here I am writing here theta by 360 pi r square minus area of triangle OAB. Now here, because this is a triangle, it can be obtuse triangle, right triangle, acute triangle. So there are different cases. So here, how do we calculate? Because calculating area of triangle is the most important part. Now you know that if my sector, the central angle is 90 degree. Now if it's a 90 degree angle, I can directly use half base into height, because here this height is nothing but, this is base, this is height. Base and height, they both are r, so it will be half r square. Now, if it is a 60-degree angle, how do we take it here? Because it's a 60, and you know that it's an isosceles triangle, the base angles also will be 60 and 60 degree, right? Because the angle opposite to equal sides are equal. So this becomes equilateral triangle. And how do we calculate equilateral triangle area? Root 3 by 4 a square, right? And a is your r, because these are the sides. It is going to be, every side is going to be r. So it will be root 3 by 4 r square. Now similarly, the again the important part here, it is 120 degree central angle. Now this total angle, it is 120 degree. Then how will you take it? We'll take here half base into height. So what we'll do, because it's isosceles triangle. Now you know that this triangle will be congruent to this triangle using RHS. Triangle is congruent to this, so angle AOP will be equals to angle BOP. So each angle 120 will become 60 and 60. Now you will consider one triangle, and you will apply trigonometric ratio to find out H, which is OP, to calculate the area of triangle OAP. How can I do it? If I take cos 60, it will be adjacent by hypotenuse. So we can get it here, height as r cos 60. Now if you consider this triangle, if this is 60 degree, this angle is 30 degree. So we can take here opposite by hypotenuse also, but if you are taking sine 30, so sine 30 will be h by r. Using this also you can get the height of the triangle. Now once you get the height, base is here, base also sometime chord length is given or chord length is not given. Again you can use here trigonometric ratio. So how can we do it here? I can take here sine 60, right? I can take sine 60 will be equals to AP by OA. So AP is going to be here OA sine 60, right? If I need to get it. Now double of AP, because this side is equals to this, is going to be AB. So AB will be 2 times AP. And calculate the area of triangle. Now sometimes you get these kind of question also where it is area between two sectors. Now this is one of the sector which is subtending angle theta, which is having radius phi. Now what is another sector here? OCD here. So this is OA is 5 centimeter, is it is extended by 2. So the radius of outer sector, it's a OC, and this is OA, it's going to be 5 plus 2, which is 7 centimeter. Now how do we find out the area of shaded? Area of sector OCD minus area of sector OAB, right? So area of sector OCD is going to be, theta is same, theta by 360, you will take capital R, which is the bigger radius, outer sector radius, minus theta by 360 small r, which is 5 centimeter. Now from both, because calculation will be lengthy, you can take theta by 360 into pi times r square plus minus r square. So all these formulas you have to remember and then solve the question.
Thank you for watching this video. Please like, share and subscribe. Also, keep practicing.